Only here to give you another higher tier GCSE lesson to occupy your summer with. I know it's the Easter holidays, but there'll be some people desperately not wanting to fall behind, or some people who are getting bored. Maybe you've had a bit too much of the heat and you want to be inside for a bit, or maybe you just want to touch up on your math. Maybe maths was one of your favourite things at school, or it still is, and you're missing out on it. So this is a chance for you to learn those things. Hopefully this will help you with frequency polygons. I'm going to be covering what a frequency polygon is, why we're using continuous data and how that works, and how it's different from other normal bar charts. So without further ado, let's get cracking. So welcome back. I'm cooped up in my office. It's a lovely warm day and I'm stuck inside just finishing off this video. I'm going to probably go for a long run in a little while we're still allowed. So before I do that, let's learn about some frequency polygons. Let's head over to my studio. I'm going to call it my studio and I don't care because it's my studio. And we'll find out what's going on. So in my studio, we have got frequency polygons is what we're learning today. And we're going to be looking at group data, frequency bar charts, frequency polygons, and then reviewing and challenging. I will warn you, this is a short lesson today. There's work to do for you guys, less to me. It might only be about 15 minutes. We will see how long it takes. I will definitely not admit to you that this is the second time I've recorded it, because the first time I did the full recording, I had muted my microphone. I will definitely not tell you that because that would be embarrassing and I wouldn't admit to those sorts of things to you, would I? So, we're looking at the background to this. It comes from grouped frequency data because we are dealing with data that's continuous. If you are not clear at all on what continuous data is at all, my lesson this morning for year 3 to 6 covered discrete and continuous data, but you possibly can remember continuous data is just the data where it's measured, so you can always measure more accurately. If we think for a second about, there's data you can count. For example, the number of times I've done something has to be a whole number. 1, 2, 6, 12. It's not, I can't say, oh, how many runs have you been for? Oh, I've been for 4.729332. It's not going to how it's going to work. However, the distance I run would be continuous because it depends how accurate I measure. But the minute I start that GPS and stop that GPS, that's when the distance is measured, and it could be more and more accurate. And anytime you can be more and more accurate, that's continuous data. We then get a group frequency table, and the group frequency table includes all the values, remembering that it will have a point at which the values stop being there and start going into the next one. For example, on the example warm-up question we've got, you're going to be asked to find the mean from this data. I'd like you to pause the video, have a go at the question, and then I'll mention the answer and I'll talk about how I did it. Hopefully you did that. If you didn't, well, what are you doing? This is for you. This is your lesson. If you're skipping past things, well, you're not going to learn, are you? If we have correctly put the midpoints in of 2, 6, 10 and 14, then done the midpoint times the frequency, you should get a total of 80 over 16, which is 5. Notice I always include my division. It is an estimate, though, because we're not doing any rounding, guessing. It's an estimate because we've used midpoints. Therefore, we're going to be looking at frequency bar charts before frequency polygons, because frequency bar charts are where they come from. Frequency bar chart is like a normal bar chart, except it differs in a couple of key respects. In a normal bar chart that you first learn about in like year 4 or 5, you're creating these bars. They should, if you're doing them correctly, always have gaps between them. This is because the data is discrete. That is, there's no links between them. The difference when we come to doing a frequency bar chart is best highlighted on the next slide, where I've drawn this beautiful, neat bar chart. You can tell it's my writing and not what a picture I've downloaded off the internet. You'll notice there's no gaps between the bars. The second thing you may notice is there's no labels. It has not got a label at the bottom for 0 to 5, 5 to 10. Instead, it has a number line. That number line, which is beautifully straight, is 0, 5, 10, 15, 20, which means there are 2 frequencies, there are 2 readings, and imagine these are bags of flour, bags of sugar. You can't get flour anywhere at the moment, but imagine these are bags of flour. There are 2 bags that are between 0 and 5 kilograms in weight. 4 bags are between 5 and 10. Note again, 10 exactly, which is very unlikely to measure anything in 10 exactly, would go in the group depending on whether you've got greater than or equal to or less than or equal to on the original chart. So the two main differences here are there's no gaps, and below the line is a number line, not a scale. Now, how would we convert? So it is a scale, not labels. How would we convert this to a frequency polygon? In order to do this, we're best served me zooming over to my whiteboard. So at my whiteboard, you can see I've already imported a copy of the video. The graph. I can do talking, honest. The one way of doing it is to draw the bar chart first, then put a cross on all the midpoints, just like this, and then with a straight line, connect them all. With a ruler and a straight line. Do not do a curve. This is why I refer to a frequency polygon as a midpoint mountain. It's a bit like a mountain range. So that's why I sometimes put a little bit of snow on it, just to remind you, it's a bit like a mountain range. But then we finish it off, we always connect to the smallest value and the largest value to connect it down, and that is my frequency polygon. Now you will notice from all this data, all I've done is use the bar chart and connected the midpoints of each one. That's the midpoint there, that's the midpoint there, that's the midpoint there, midpoint there. Therefore, we don't actually really need to use the bar chart. If you're comfortable that they're all the midpoints, then we can go straight ahead and make a frequency polygon without drawing the bar chart first. How would we do that, I hear you ask? Don't know how I'm hearing it because you're not here, but we do the following. Here is one I prepared earlier. We have a frequency chart, and I can write immediately what the midpoints are. 5, halfway between 0 and 10, 15, 25, 35, and 45. Therefore, once we have those midpoints, we are then able to easily create our chart. Here's my axis. I'm trying to make it as neat as I can. I notice it goes from 0, goes up in tens, 10, 20, 30, 40, 50. And because I've learnt that this is a frequency polygon, it's a scale, not labels. You do not take a label and write it down here. That would not be correct. Instead, we're now needing to look at what the biggest numbers is, and I think 38 is the biggest number, so I'm going to go up to 40. It must be steady improvements. I've seen some people when they do these trying to put all these 4 numbers on here. That doesn't make any sense. The scale must be a regular scale. We then have time in seconds, and because time is a measured thing that can be measured more accurately, it's continuous, so we know we're likely to need a frequency polygon. The second reason we know is because it says frequency polygon. So in order to do that, I'm going to plot each number, 5 against 7, roughly speaking. Ideally, you'd use graph paper for this if you've got some, but I'm just doing a version to make sure you learn the actual skill. 25 up to 38 goes about here. 35 up to 16 goes approximately here. And 45 goes to 12. Do not forget to plot the lowest value and the highest value. So I'm also plotting that, and then complete my mountain using straight lines. Doop, doop. Now you will not get any marks for drawing snow on these mountains. You can just see why I call it a midpoint mountain, but I don't think mathematically it's frowned upon at least. But some information we can get from this. The reason for doing is it's a visual representation. We can clearly see most of the data is between 10 and 30. It might be possible to see the numbers, but from the graph we definitely can see where most of the data lies. It also helps us to clearly see, especially imagine if we had lots more data, this is called the modal class, which is basically the interval 20 to 30 is the group where the highest frequency is. And you can see it's the peak of the mountain. It's the highest place, the group with the highest, or the class, or the interval with the highest frequency is your modal class, modal interval, modal group. So it allows us to find data and see the data quite clearly. So what am I trying to say to you? I am trying to say that this is a quick video. We've covered everything, I think. What I really want you to do is realise that we are focusing fully on completing your frequency polygons by plotting the midpoints and plotting the highest and lowest values. This should make, if you use a ruler and pencil, straight lines, it should make a nice little mountain range effect. We are data in review. We are looking at continuous data, so grouped frequency table data where you can always get more accurate by measuring. You can always measure between different bits, and no two bits of data are the same as each other because you can always get more accurate and separate them. There's two options for that data. We can use a frequency bar chart, which is different from the original bar charts we used to do. There's no longer gaps between it if you're doing a frequency bar chart, but instead of labels down the bottom, you must put a number line in the bottom. You do not put like the whole of the range in. You never write that range down the bottom. We can use that bar chart by plotting the midpoints of the tops of the bars, or forget the bar chart altogether if we're doing a frequency polygon and just plot the midpoints, and this is why I call it a midpoint mountain. And then don't forget to use the highest and lowest values. So my challenge for you, I want this to be an interactive channel. How can this be an interactive channel? It needs you to be involved. I'm putting this video out, and I'm trying to put videos out throughout the holidays for you. It's not holidays, for the lockdown, throughout the time that we're not able to learn. And I'll possibly continue after we're back at school. However, I will thrive on the interactivity of you. If you send me pictures of you working, pictures of the work you've done, ask me questions, especially using the comments to each video below. It allows me to engage with you like I would do in the class. This is why I'm a teacher. I want to help you learn. I don't want you to watch a video and walk away going, I didn't understand that bit, I didn't understand that bit. Please ask questions. I will respond to questions to the videos. I will make it about you. There's also, as well as the worksheet challenge you can see on the screen, there's a Taskmaster challenge each week. This is more of a live interaction. You've only got a few days to do this. This is a challenge for this week. So try and put a hat with your hands behind your back and send me the pictures of you doing it, or even videos if you do it. Try and get your family involved. Try and get different people to do it. People send me videos of it. I will try and integrate that with the video even more and make it an interactive experience for you. A lesson where you've had involvement in what's being shown. It might be appearing quite dry at the moment. That's because it's only me, and I am quite a miserable old man. So the more you get involved, the better it is for everyone. There's also a sharing challenge. I challenge you to share this to the channel to 2 people you think would benefit from it. I really want these videos to be shared, not because I want to be a YouTuber, not because I want to be some sort of YouTube sensation. That's not going to happen. I'm a maths teacher who's approaching 40. I am just here to try and help you learn. But the more people who are on this channel, the more people who are watching the videos, the more I'm likely to get good feedback. I'm going to get people asking for certain topics. I'm going to get interaction from you so we can make the learning better. And that's where you come in. So meet these challenges, go away and let me know how successful you're being. I have been Mr. Harris. If you've liked anything that you've watched today, please do click it on the like. It's all good for getting it distributed for more people. Consider subscribing to the channel. I'm always going to be coming back 2-3 times a week with new content for you. All the way through lockdown, I want to help you learning, especially year 10s who want to make sure they don't miss out. It's up to you for doing the work. I can't make you do the work. I can only provide it for you if you want it. But no one should be moaning when they come back and saying, oh, I didn't have an option to, because that's what I'm here for. And that's why I want you to share what I'm doing around with everyone. Thank you so much for listening to me waffling on. I promise you, it's not the embarrassment of me repeating myself over and over because I've had to edit this together because I've got my words wrong. I promise. So, on that bombshell, I'm going to go out for a run. Thank you so much for listening. I've been Mr. Harris. You've been awesome.